Okay, sorry, the last video we had a little bit of a problem, technical problem. Let's get back to what we were talking about before. So let me just redo it here. We're talking about a situation where you have a pillow and an egg being dropped onto the pillow. So what we're saying is, very simply, is that right before it touches the pillow, this little mass of this egg has some velocity v. Whatever that velocity is, it's heading downward. And so at this point right here, when it just touches the pillow, it's got a momentum m times v. When the egg finally comes to rest, what happens is the pillow tends to sag in a little bit, and now the egg is here because the pillow cushions the egg. I seem to have the microphone. I'm not sure why the light is out on the mic, but I hope that this is still recording. So I'm going to continue as if it is recording because we're almost going to be done with this. So hopefully we're still recording here. And we have the egg coming to rest over here at this point where the velocity is now 0. So the momentum here is 0. So this change in momentum from just where it touches the pillow to just where it comes to 0 is going to be mv, which is the initial, and 0 is the final momentum. So the change in p is the final, 0 minus mv. So the change in momentum is minus mv. In the situation where we have no pillow at all, you have egg just as it touches the floor, hitting the floor with a momentum mass times some velocity v, and there's almost no time at all that takes place. So over here you have a long period of time because it's being cushioned before it stops. Now it stops almost instantaneously in a very short time, and now the final momentum is 0. So initial momentum is just as it touches, and almost an instant later it's at a 0 velocity. So the change in momentum here is the final momentum, which is 0, minus the initial momentum, which was mv. And we have this change in momentum equal to negative mv. So what I wanted to say was that the change in momentum, whether you're on the pillow or on the floor, is exactly the same. It's minus mv. So if that's the case, then the change in momentums are the same. So up here, if we put this in blue, there is a force 1 times time interval 1 is equal to this change in momentum. And over here, force 2 times time interval 2 is equal to this momentum. And they're both equal. So these two guys are going to be equal to each other. So we're going to have F1 times delta T1 has to be equal to F2 times delta T2. So in order for these two to be equal, you see that in this case, when the egg is just hitting the floor, this force has to be large because this time interval is small. This time interval, T1, is larger because it's on the pillow, so it's taking longer to slow down. So this force, F1, is going to be smaller. That's what I was trying to say. So basically, this is an impulse issue whereby if it takes longer to slow it down and stop it, the force is going to be less. That's like when you catch a baseball, you increase the time that it's in contact with your hand to stop by moving back with the ball, following through with the ball. Same happens with the egg. Okay, so that's about it, what I want to say about impulse, and the next video will be just for the honor class or the accelerated physics class, because I wanted to touch on the conservation of momentum, which the standard class didn't have. And then after that video, we'll be back to more review.